Hi, and welcome to a quick review of context, writing equations of lines given word problems, right? Given stories. So let's look at this story. We've got 3 times as many boys than girls commenting on tweets from LeBron James at any given time. And we want to complete the table and then write an equation. And so we're just going to use logic, right? If one girl tweeted, then 3 boys would have tweeted, right? 3 times as many. If 2 girls would have tweeted, 3 times as many as 2 is 6, right? 2 times 3 is 6. 3, 9, et cetera, right? So we're just using common sense. And even if we hear ourselves, we know that the slope is 3 because we're multiplying everything by 3. That's our rate of change. But just in case we were just writing them down and not paying attention to what we were saying, we can do the who's. 12 minus 9 is 3, 4 minus 3 is 1. We can continue, we're going to keep getting 3 or 1. So we know just looking at this, hey, the slope is equal to 3. Now, the interesting thing is here, we could go ahead and find the y-intercept in a unique way. Like, for instance, let's go ahead and take this away. If 0 girls respond to LeBron James tweets, how many boys would respond? What's 0 times 3? That's right, just 0. So our y-intercept, if we use logic, is 0. All right? If we didn't use logic, and we went ahead and did our squares and stuff, we could do that. But I think this makes sense that our y-intercept is going to be 3. So we'll have y equals mx plus b. And so we've got y equals 3x plus 0, or we would write it as y equals 3x. If you don't like this way, just kind of using logic to find y-intercept, you're welcome to do the slope-intercept form, and you'll get the same answer, y equals 3x. All right, so this next one, oops, marker boards, we're not going to do that. That's when we were in class. All right, this next one, we've got Macy going to the movies with friends, and she's decided to buy popcorn and candy for the whole group. Popcorn costs $4 and candy costs $2. Write an equation that represents the possible combinations of how many she can buy if she has $50 to spend. So this is different, right? I don't see a slope. I don't see a y-intercept. I'm really confused about this. And so then I remember, oh, you know what? This is going to be like standard form. Remember when we had some lines in standard form like 2x. Oops, I'm in yellow. Let's do a purple. Like 2x minus 4y equals 10. Sometimes we saw lines like this, remember in graphing lines, where we'd isolate the y, we'd get y by itself, get everything else over, and then we'd graph it. But this form right here is standard form. And this is going to actually help us know how to set up this problem. Because we've got 2 things going on, right? Let's say that x is equal to the amount of popcorn, right? I was going to say number of popcorn, but how about amount of popcorn? Because it's really, how many popcorns is she going to buy? Yeah, containers of popcorns. And we can have y equal amount of candy, right? So we don't know how much she's going to buy as far as the amount of popcorn containers or the amount of candy. But we do know one thing. We do know that, let's switch to a green. We do know that the popcorn costs $4. So if she only bought 1 popcorn, it'd be 4 times 1 is 4. If she bought 2 popcorns, it'd be 4 times 2 is 8. If she bought 3, 4 times 3 is 12. But we don't know how many she bought. X stands for the amount of popcorns, I like that, popcorn that she buys. And so we know that each popcorn that she buys is going to cost $4. So 4x represents the amount of money. This is going to be the cost of the popcorn, okay? And then same thing, we can do the same thing with the candy. We can think, well, let's get some hot pink going on. Maybe that wasn't quite, that's like more of a corally color. We can say, since y represents the amount of candy, and we know candy costs $2. I mean, apparently all candy at this place costs $2. If she bought 2 candies, it'd be 2 times 2. If she bought 3, it'd be 2 times 3. If she bought 4, it'd be 2 times 4. But we don't know how many she's going to buy, right? So y stands for the amount of candy she's going to buy, and we know that the cost is 2 times y. So the 2y is the cost of the candy, depending on how much she buys. And so when we think of standard form, we're like, okay, let's put it all together, right? The cost of the popcorn plus the cost of the candy has to equal how much she has to spend, right? Now she may, in this word problem, it's not really true to life because obviously she's going to get some change back, there's going to be some tax, and so this is just a basic kind of representation of this type of problem. But she's got $50 to spend, and apparently in the problem, she wants to spend all of it. Kind of insinuates that. So we're just going to have 4x plus 2y equals 50, and that's going to set up the different combinations that she could get depending on, if she bought, well, let's say she bought 25 candies. Well, oops, there's all her money. 2 times 25 is 50. She's going to buy zero popcorn, right? Or if she buys, okay, I'm going to just like keep guessing and doing things. Let's say she buys 5 candies. That would be $10 on candy, which would leave her $40 off for popcorn. That means she could buy 10 popcorn. So see how this equation, it's kind of cool. It leaves us with some idea of what she could buy of the candy and how many she could buy of the popcorn within her restriction of only spending $50. Only $50. That's a lot of money to spend on popcorn and candy. So we're done because it's just us to set up the equation of this situation. All right, we're not doing marker boards. All right, Josh's bearded dragon lizard grows 0.25 inches per month. I don't have one. My daughter has a bearded dragon lizard, and a lot of their length is in their tail, but they're very, very cool. So after 8 months, it is 16 inches, right? An equation that represents the relationship of the total length of the lizard and the number of months. So I'm looking at what they're giving me, and I see 0.25 inches per month. When I see per, that's a rate, right? Miles per hour. That's the only thing right now I can think of is miles per hour. I'm sure if I didn't have a migraine and I was exhausted, I could think of other things. But when we see per, we know it's a rate. So we're going to go ahead and say our rate of change, which is our slope, is 0.25. And we're like, yay, thank you for giving us a slope. That means we don't have to make a table. We don't have to find the slope on our own. And then here it's interesting. After 8 months, it's 16 inches long. This is interesting information. And so I realized, oh, when they're giving me 2 numbers that are connected, it's a coordinate point. All right, so they're giving me a point. They're saying at 8 months, it's 16 inches long. So I'm like, okay, I'll take that. Thank you. I've got my slope. I've got my point. And now I'm going to go ahead and put it together. I'm just double checking that I am recording. All right, so I'm going to put it together into my slope-intercept form. And once again, you know that I write it this way. And so I'm just going to plop things in, right? My 16 goes there, and my 8 goes there, and my 0.25 goes there. And I'm going to do something a little thinner. So here we go. So we'll have y minus 16 equals 0.25 times x minus 8. And we'll go ahead and distribute. I don't know what's behind this thing. We'll find out if I can write on it. So we'll have 0.25x. 0.25 times negative 8, well, that's 1/4 times negative 8, which is negative 2. Let's go ahead and add the 16 to both sides. I can write on this thing. And we'll get y equals 0.25x plus 14, which is interesting because it actually tells us in the beginning when this lizard was born, the dragon lizard was born, it was 14 inches, which, all right, this is not true to life. They're born, they're really teeny tiny, they're so cute. They're more like lizards you'd see in Florida. I grew up in Miami, and I'd have those little bitty lizards that would run all over our fence and patio, and then we had Cuban anoles, which were huge, even bigger than the bearded dragon. All right, a little too much info there, but we're done. So when we see problems like this, and we see the word per, they're giving us our rate. And then when we see that they're giving us information where 2 numbers are linked together, we know, oh, that's a coordinate point. And then we know what to do once we pull the information out from the problem. All right, let's see one last time. It costs $185 for a 2-month country club membership and $457 for a 6-month membership. Okay, I don't see per, I don't see, I am really seeing 2 points, aren't you? So these are 2 numbers that are linked together, $185 and 2 months. Here's another two numbers that are linked together, $455 for 6 months. All right, And so, what I'm going to do is I'm going to write them as points. Now I'm going to be really careful. Just because the 185 comes first doesn't mean I'm going to write it first. Whenever we see time, time is always going to be our independent variable because time is independent. I mean, time just keeps going. We can't stop time. We can't control time. Time does what it wants. It's independent. That's like the most independent thing we can even think about. It's just time. And so we remember way back when we talked about, X and Y, and X being the independent and Y being the dependent, probably going back to middle school talk. But it's very important to remember when you do have two numbers and one of them is time, that goes first. And it makes sense, right? It would make sense to look at this coordinate point. Oh, for a 2-month membership or 2 months in a country club, it's $185. It would be weird if it said, okay, $185. Oh, we could say that, couldn't we? $185 for 2 months. We're just going to remember time goes first. All right. And then my other one, same thing. In 6 months, it would cost me $457. So this is a pain because we have the 2 points. And so we need to go ahead and find the slope, right? So we're going to make a table, throw everything in the table. All right, 457. Man, I don't have a calculator. What am I going to do? Do some calculations to the side. All right, 457 minus 185. We've got 2, 15 minus 8 is 7, 3 minus 1 is 2. Hopefully that's right. So it's 272, and 6 minus 2 is 4. All right, hopefully 4 goes into 272. So, and once again, you can pick up a calculator. I just don't have one right now because I am at my board tethered to my mic, and there's not a calculator in sight. Anyway, so 32, and that would be 8, so 68. So hopefully that is the slope. I think that's right. So my slope is 272 over 4. And if you used your calculator, hopefully you got 68 as well. And you know what? If I made a mistake, that's okay. And so that's my slope, and then I'm going to pick a point. I'm going to pick this point just because it's a little bit smaller. And so next thing I'm going to do is put it all into my y minus my box, so my point slope. And so I'll have y minus 185 equals 68 times x minus 2. And then, oh my gosh, I'm going to just be tortured, aren't I, doing this math in my head. So that's going to be 16, carry the 1, 136. We'll add 185. 185. 185 minus 136. Well, 15 minus 6 is 9. So minus 3 is 4 is 49. So hopefully that's right. If I made a mistake, you've caught it already, but hopefully I didn't. All right, so that's it. Those are the ones that you're going to see on the test. Just make sure that you're aware, and be like a detective, be an investigator, like, oh, what do they give me? If they give you 2 points, then make sure you have a calculator in your hand. I think that's the takeaway from this. Make sure you have a calculator in your hand. If they give you the rate and a point, make sure, once again, too, this is time, months, that's time. Notice we put the time first, 816. So slope and a point, we just plop that into our point slope. Isn't that interesting? Point, slope, point, we pop in a point slope because they gave us a point and a slope. And then what else do we see? We saw the one that looked different. This is like standard form, and that just took some logic to think about. And so hopefully you get some more practice with that. And then that first one was just noting, oh yeah, this one's pretty straightforward, isn't it? My slope is 3 because 3 times, that's another indication that we're talking about a rate, 3 times as many. All right, thanks for joining me. I will see you in class.